SNMP. In this nugget, we'll be taking a look at SNMP, or the Simple Network Management Protocol, and we'll start with an overview of it. It's kind of an overlooked topic. So with SNMP, we'll see what it's used for in constructive network management, and then we'll see how we can later on take advantage of those things. But one of the things you'll see there is that it uses strings. These are kind of not really passwords because they're pretty rudimentary, but they're ways of attempting to secure the traffic between SNMP hosts. Then we'll also take a look at ways that we can exploit SNMP, where we can figure out what those community strings are, either by guessing or by doing some kind of a coordinated attack against them and figuring out what those passwords are, and then potentially changing or altering information. You know, of all the things that hackers go after, I think one of the things that is possibly the most overlooked is something called SNMP, or Simple Network Management Protocol. It's in use just about everywhere, and in a lot of places it's on network devices and you can't turn it off. It's just there whether you want it to be there or not. Now, some of those are going to be kind of ambiguous and really won't be of much value to administrators or to hackers, but a lot of those will give us the ability to not only learn a lot about the network that we're scanning, but also about the specific hardware on computers, the specific kind of network devices that are there, and we also have the ability, if we work a little bit harder at it, at being able to hack into these items. Let's go ahead and take a look at what SNMP really is. And as I said before, it's really Simple Network Monitoring Protocol, and here's our overview for it. It really works on a client-server basis. And that'll be best described when we take a look at the PDUs, or the Protocol Data Units. This is kind of discrete little packets of information that's sent across the wire when something queries a network device. You see, what happens is the network devices themselves, well, they're going to have a table on those devices that's going to collect information over a period of time, and it just holds it into that table until the manager polls that agent. And then when it does that, it gathers the data out of that table to be able to get the information from that particular client. And these are the messages that we use to get that information. First thing is a GET request. This is just going to query for some value stored within that device's SNMP database. There's a database that's stored on each one of these devices. And that database will store something called an object ID, which we'll look at in a little while here, as well as information associated with that object ID, a value for each object ID, some of which, again, can be very revealing or very susceptible to hacking. Now, the next thing really is the same as GET. Get next, those are really the same thing, except that get next can also be used to kind of, not really script it, but you can use utilities that will kind of sequentially go through the next object ID, and it sequentially goes through them so you don't have to manually keep typing get over and over and over again. I mean, there are thousands and thousands of GET requests that could be made, so it's not really humanly possible to just sit down and manually type them all out. And we'll see all this as we start to work with SNMP here a little bit later. We'll take a look at these GET items. Then there's also something called a SET request. This is where we configure devices and we set the variables on those specific devices. So, for example, if I was hacking into an SNMP device and I wanted to change a value to do something like a spoofing attack on that device, then what I would do is to set a request. I would tell it that that device is actually something else, or that I would change its IP address, or something like that with a SET request. And then a trap this is going to be something like an alert or an error message, and it's going to be sent back to the messenger from the device. The trap messages are initiated from the device manager. Otherwise, any other messages that we see up here, these all flow from the manager to the device. And when I say manager, by the way, that could be a number of different things. A lot of times that's going to be something like a software solution or a network management solution. And if it's working properly, we're not talking about hacking here, but just normal network administration. Periodically, it'll send these messages, usually a get message, to our specific devices. Now, many network devices can also be configured with a trap. So, for example, if they trigger a certain amount of network traffic, or if it's some kind of a storage device and it exceeds a certain amount of storage, then what can happen is it can be configured to send out a trap to our management, and that would again typically be something like network management software, and then it would send an alert or an error message back, and then depending on the software it could page an administrator saying, such and such a device is almost out of storage space, or a specific router has an unusual amount of traffic going through it, could be susceptible to a denial of service attack, or maybe it's just a real busy day and we need to alleviate the load on that router. And then as I started to allude to earlier, we have a management information base. That's our database, and that stores our object IDs. And there's, again, just thousands and thousands of those things that can be stored. And again, we'll take a look at a lot of those a little bit later on. They'll come into play when we start to work with certain utilities and things. You'll see a whole bunch of object IDs. Now, this all really revolves, in terms of the management, revolves around something called a community string. It's not really a username. It's not really a password. It's more like a shared secret. And if you work with one of those, Linksys home, wireless routers or something like that, you know what I'm saying. Because for those kinds of devices as well, you enter in a shared secret, and the network card on the client side has to have the same shared secret as what's configured on that wireless router. Well, it's a similar idea here. We don't have usernames and passwords. Instead, we have kind of a shared secret. This is how we authenticate our SNMP traffic. And by default, you have two community strings. Well, the first one is just called public on most devices. And this can be changed, but for most of the time, out of the box, that's what it's going to be called. This gives you read access to that device. Now, as a hacker, typically, you want read-write access because you want to get right in there. But hey, even the public access can give you an awful lot of information, and it's an excellent tool for being able to footprint things. Another reason that you might want to just be satisfied even with the public information is that it can sometimes give you clues as to what the private information might be. A good example of that is this. One of the first things I'll do if I'm trying to scan a network, trying to scan some SNMP devices, is if the word public does not work, and it doesn't seem to be able to get me to the SNMP device, and I can't get into the database with the word public, then what I'll try next is company public. So if the name of my company, I've got a domain in here called mail.com. So if the name of my company is mail, I would try mail-public. And very often, that is what administrators will choose. I don't know why. I mean, it's kind of common knowledge. I think one reason why is because although network administrators use SNMP for their normal day-to-day maintenance, they don't always see it as a security issue because it's not very secure in the first place, so they don't pay that much attention to it. They may have a Kerberos authentication method and smart cards and fingerprint scanners and all that kind of thing on their logon side for their users. But when it comes to managing their network devices, they're just using mail public. Well, if they're using mail public and they're that careless with the public side of it, what do I need to do to get to the private side? Well, again, the private string is typically also private. But if they do change that, again, the first thing I'll look for, if I'm just doing a guessing attack against their string there, will be mail private. And very often, that actually works as well. And that, again, gets you read-write access. And in terms of the network traffic, by the way, if you want to do some sniffing, sniff on UDP61. That's where your get next, and set requests are all sent. And then UDP162 are where the traps are sent. So again, with some versions of SNMP, these passwords or these community strings can be passed in the clear. Look out for those ports. That's probably what's going on. Just take a look at the data, and you will very likely find some kind of a community string. And by the way, another thing about these community strings is once you've broken one of them, it's often a house of cards. I mean, some corporations have dozens, if not hundreds or more, network devices between routers and switches and servers and all those kinds of things. And by the way, this doesn't just apply to routers and switches. This can apply to a Windows 2000 box, for example. Well, in any case, it seems impractical for most administrators to name each network device on their network a different community string, so they'll name at least a whole department using the same private string, or a whole site using the same string. And so it's really house of cards. Once you figure out one, good chance you can get some of the others there as well. So then when it comes to the SNMP hacking, the public, as I mentioned before, that's just going to give you read-only information, but that's very, very useful for footprinting. You can find out a lot of things that we can also find out using other tools, for example, such as how long a host has been up. Or we can find out what version or what operating system or what processors a specific computer is running, for example. All that kind of stuff can be done via footprinting using the public community string. For the private community string, well, you can do some damage. You can change things. It's very easy to configure a denial of service attack, and it's very difficult for an administrator to track down what damage you did because, again, there's thousands of community strings. Who knows which one you changed? So you can really do some damage once you learn that private one and start writing some malicious changes. The strings that are sent, again, they're going to be in the clear. That's V1. That's version 1, SNMP version 1. Now, as I mentioned before, you can sniff those using a packet sniffer. And this was SNMP version 1 was really created back in the 80s, back before security was a real major concern. Of course, since then, security has become a much greater concern. Well, you see that I've got version 1 there, where the community strings are sent in the clear, and then there's version 3 here. What happened to version 2? Well, some devices use version 2, but overall it was kind of passed over, and it was overlooked in the networking community. Version 3, however, is pretty good, and it hashes the passwords, and any of the traffic that it sends back and forth, it hashes that as well. And that helps to guarantee that that traffic has, or those packets have not been intercepted and manipulated with some kind of a man-in-the-middle attack or something like that. But nevertheless, these passwords, these public and private community strings, are pretty easy to brute force. There's a number of different tools out there that can do things such as, brute force attacks, or usually you should start with a dictionary attack first, because brute force attacks can take a little longer, sometimes a lot longer to work. But try starting off with some dictionary attacks, and then you work your way up to a brute force attack if necessary. This is very similar to what we'll do for cracking other passwords that we'll see later on in our series when we start cracking Linux and Windows passwords. All right, now here I've gone to a Linux box where I'm just going to use SNMP get, and this is something that you'll have at a command line on your Linux boxes, and I'm going to send it to 10.10.10.42. I'm looking to use the word public as the community string. That's what -c is, the community string of public, and I'm going to go against this object ID. I'm going to query using that object ID, and I'm hoping to get some useful information back. Now, a couple of things. Number one, if the 10.10.10.42 device does not use the community string of public, this won't get me anything. So also, that particular device has to have some kind of an SNMP service enabled. Again, a lot of the network devices out of the box already have SNMP enabled. If it's a Windows box, however, it'll have to have the service started up. And a lot of times administrators will do this, again, especially if they're remotely administering those servers and they want to be able to use SNMP or SNMP tools of some kind to be able to remotely manage that machine. So anyway, I'm going to enter in this object ID. This is just an object ID. Again, I told you it was integers separated by dots. And you don't need to memorize that. But there's certainly places where you can get a lot of information about object IDs. And we'll be looking at a tool called SolarWinds shortly here that gives us a lot from that as well. So I press enter and get a pretty quick result back here. First of all, what kind of hardware am I running? Well, it looks like an Intel box, x86, Family 15, Model 4, Stepping 8. Now, that doesn't mean a whole lot to us, but from a practical administrator standpoint, whenever you add additional processors to computers that can accept multiple processors, you have to have the exact same stepping on them, otherwise they'll be incompatible. So, just a little 2-cent tip for you right there. Anyway, software here, what are we running? Windows 2000 version 5. So, I've footprinted and identified what hardware basis it's using, what kind of processors it's using, and what operating system that box is using. Now, I mentioned, again, these numbers up here can be kind of cryptic. Another thing you can do if you want to find kind of a plain English translation for what that is you can do, and I'm just going to go ahead and use the up arrow so I don't have to type that whole thing in again. But I'm going to use SNMP translate, separated by space and that same number, and that tells me what this is. It's just the description of that specific device. Now, the next thing I would want to do is the object ID on that device, it might not go 1.3.6.1.2.1.1.1. The next integer might not be a 1. I really don't know what it is, and there's so many numbers involved there, it could be nearly anything and difficult to calculate. So what I'll do instead here, if I want to figure out what the next SNMB, the next value in the management information base is I'll do SNMP get next. And then the IP address again, 10.10.10.42, and then followed by a -c for community string public, and then whatever appears after .1.3.6.1.2.1.1.1.0. So what I'm asking it is, what's after this object ID? And it'll tell me that the next object ID is .311 and the rest of that. Now, it would have taken me forever to just probe against all these numbers until I finally came up with this. In fact, it's really not humanly possible for me to have been able to do that within my lifetime. Now the beauty of this SNMP get next item is not that I can just sit at the keyboard and keep typing over and over and over again what I think the next MIB is going to be. The real beauty of that is it can be hard-coded into other applications or scripted so that you can recursively get next, get next, get next, get next, get next, and derive information out of each occurrence of whatever it is able to return. So we call this SNMP walking or MIB walking, I've heard it called as well. So let's go ahead and give this a try. Let's go ahead and, first of all, just out of curiosity, see what this .1.3.6.2 is. Okay, so let's do a SNMP, if I can type here, SNMP translate .1.3.6.1.2.1. And then that's going to give us our MIBs there, okay? It's going to give us a range of MIBs. So next thing I'll do then is SNMP walk, SNMP walk, and then followed by a 10.10.10.42, community string of public, .1.3.6.1.2.1. Now, for you to do hacking, you don't have to have just guessed what numbers to type in there. I'm feeding that to you, okay? Just so that you know that this is where we get a management information base. In that management information base, we'll then get our subset and all our family, and we'll walk the tree, so to speak, starting from this range of numbers. So we'll walk it from here and read real fast here, okay? Do you get that? Do you get that? Good, 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 good. Okay, good. Now let's hopefully you've memorized all of that and can tell me what I need to hit next in my attack. Wow, was that ever a whole bunch of information? Well, what we can do there, instead of doing all that, you really need to pipe that out to a text file. So I'll just call this SNMP. And press enter, and then it's going to dump it all into an SNMP file. It'll be much easier to read. SNMP, so we'll do a more SNMP, and now we'll just be able to scroll through it. You can use a text editor, or other things you can do is using certain tools, you can export this also into a CSV or a spreadsheet, which allows you to easily manipulate the data as well. So in any case, you can just go on and on here with looking at this. And I'm just going to, it's too much information to go through all the way through. I'm just going to go through a few here so that we can get some information. For example, here, this MIB shows us an IP address of what that destination host is. I already knew that because that's how I was able to connect to it in the first place. Somewhere in here, it should also tell me where it routes. So give me a routing table. So, well, there's my next hop. It's 10.10.10.1. That's its router. So even though I'm on this side of it, I can figure out what its route tables are. So we can get some of that information. All kinds of good stuff we can get out of this. And there's, again, quite a lot to see here. All right, for most of the rest of what we're going to do in terms of enumerating and hacking with SNMP, I'm going to use a suite of tools called SolarWinds. Now, if I've already installed that on my computer here, and it's the SolarWinds Engineers Edition. This is a little pricey. But I'm telling you, if you really do network management full-time, you're a network administrator, especially in an organization that can afford, some money to pay for this kind of stuff, this is the tool to get. It's probably the most full-featured tool of anything we'll use in this entire course. I mean, we use little bits and pieces of little applets to do a number of different kind of footprinting things and all of that. But this one, it just pretty much does it all, and it's real easy to use. It's Windows-based, and it uses a graphical user interface for most of what we do. So this is a strongly recommended tool. What we'll want to do with this is to go to the SolarWinds Engineering Edition, and then we're going to go down here to the Network Discovery, and then over here we see something called SNMP Sweep. We're going to go ahead and hit that tool, and I'm going to scan, how about just my entire subnet range here. So I'll click on that, and you can't hear this, but it does this kind of really strange little computer noise going while it's scanning through all of those. I guess that's their marketing people that came up with that thing. Oh, and then when it finishes just now, it gives you kind of a ding ding, like a Jeopardy ding or something like that. I don't know. But despite those bells and whistles, this just works. I mean, look, in addition to any SNMP MIBs or anything like that, it also gives me information about my other hosts. Now, I got that from other scans that I've done earlier in this series, but at least it's still useful information. And then it also tells me what name of my stuff is. Look, it says it's in a dangerous place and my SNMP is vulnerable. What is that and where does that come from? Well, I'll show you what that's about in a little while, but basically I put that in myself because I was able to hack into SNMP here. What's the community string? The community string it was able to determine is public. So pretty good start there. It doesn't show us the private string, but at least it shows us part of what we need to see. Another thing we can do with this SolarWinds tool is to use something called the MIB browser, or the MIB walker, I think is actually what it is. Let's go ahead and take a look here. We go up to the MIB browser here, and then down here, MIB walk. Okay, this is similar to SNMP walk that I talked about earlier from within Linux. Same kind of an idea here. Now, what I can do here is to identify a specific host name, one that I targeted earlier when I saw some things that appeared in my last scan. And this time, I'm going to go ahead and use a community string here. So let's just use, public, and I'm going to walk the standard MIB tree. Okay, so that goes through a few things, and when it's done, I'll come back to you. Okay, that took probably about a minute and a half, so that's why I paused recording and now I came back. But now we again can see a lot of information here, very, very useful information about what's going on, what kind of system we're working with, the speed of the network cards. These are in bytes, so this is a 10 megabit per second card, that's 100 megabit per second. So we're getting some of the information again about the usefulness of what kind of device is going on here, what kind of hardware it's got going on, what size packets it can accept. Again, IP addressing information. Bear with me just a minute, and I'll scroll on further down here to find something else. And while I'm doing that, by the way, usually the good stuff is where there's something under the value column. A lot of these other things might not be anything that we can necessarily use all the time. We see that there's an IP address there, maybe some port numbers or something. But anything that appears under value, if I keep scrolling down, will usually give us a little bit more information. And if we're going further down here, again, we can see that's an Intel box with a Microsoft loopback adapter. VMware is apparently running on this box. Hard disk, obviously, it's got a 3-button mouse. I can even get that kind of information out of it. Now this is what's good right here. Oh, I almost passed it. Here we go. Let's go further down again. These are the same kinds of things that we would see if we were to run Task Manager. Okay, this is what would appear in Task Manager. So I right-click here on the taskbar on this machine. These are not the same as what's on this machine, but I'm just doing this for illustration's sake. Processes, and we see that we have a number of different processes going on here. Well, over on that destination box, it's going to show these processes in its task manager. So this is very useful information to find out what kind of services are going on. Apparently, we're running some kind of an Apache server over there, so it's an Apache web server or something like that. We've got SNMP going. Oh, I got Snort going on over there. We'll talk about Snort later on in this series, but that would be immediately make me suspicious because Snort can be used to fool results of your scans. It's not impossible to circumvent, but that's one thing I would take a look at. So, very useful information there. That might help me from going down, a wild goose chase somewhere, because now I know that I might be getting fooled and I might take other measures. It's running DNS. You can see where this is going, see all the services that are going on, identify what might be vulnerable. I think there's SQL in there somewhere, too. My eyes must have skipped right past it, but I thought I saw SQL in there as well. Maybe there's a SQL some kind of a SQL injection attack I can launch against that host. So you see all different kinds of things, and again, now down in here we see some more plain English versions for what kinds of services are running on that host. Now, knowing how long the last one took, I went ahead and in the background started this one as well against .42. And this time I decided to use the default community string of private. And I decided to walk the MIB tree of private here as well, but I didn't get anything. It stopped. It said that host did not respond to queries using private. So apparently they're not using private for their private strings. So what did I tell you? Usually, or much of the time, a company will just change the community string to whatever the name of the company is, -private. So the name of this company is mail.com. So how about I just try mail-private. Now I'll walk that. And now we're getting results back here. Again, these community strings are probably some of the easiest things just to guess. Okay, and this one has now completed running, and again we see a lot of different services and things going on here. One thing that we see again, the names of the services that are taking place, all different kinds of information that might be very useful to us. Okay, so just for information, a lot of things you can pull out of these, and you just pretty much have to kind of go through them and pick and choose what information might be useful to you. Now, again, I can get much of the same kind of information here if I search for it using my Linux tools. However, this is going to be much easier to manage, much easier to read. And what I also like about this is you can export this to any number of different kinds of formats, to a PDF if you want. But what I really like is I can export this to an Excel spreadsheet, and then I can use the columns to manipulate the data and sort things out, alphabetically, numerically, whatever. A comma delimited file, you could use that then to export that and then import it into maybe a SQL database and manipulate the data that way. And especially since there's so much data, very useful way of working with it. Now let's take a look at another way of working with these MIBs, and that is to directly identify each part of those numbers that we were looking at a little bit earlier, 1.3. whatever. So as we go into this, let's take a look at, again, the MIB browser, and this time we're going to go to the SNMP MIB browser. Having opened this up, here's where we see familiar numbers. Now, does that look familiar? 1.2.3.6.1.1.1. Okay, so this is where we were earlier. That's where most of our queries have been going on, is down in this section of the management information base. And in this case, I'm scrolling down. I kind of scrolled that fast, so you probably didn't see it. But I went down to MIB2, and then I'm going all the way down here into host. I'm just going to go ahead and scan this. I'm going to get the tree. I'm starting with 25 down here, and you can see the whole object ID here. And I'm going to see what kind of tree information I can get out of that entire range and what kind of data it returns for me. All right, so in this we get, and some of this obviously will be information that you're really not sure what it is. I mean, what's this? Some kind of software was installed on that date at 10:49 p.m. I don't know. Who knows what that is? But some of this stuff, again, will return very useful information to you. For example, remember we looked at earlier at seeing when the last time this computer was booted. Well, it was last booted 3 days ago, but if there was a patch that came out yesterday that fixes a security vulnerability, then this machine would still be vulnerable to that, provided that patch requires a reboot. How much memory does this computer have? Oh, it only has 127 megabytes in this case. Well, that might be helpful for buffer overflows, especially if I'm a programmer. That's a little bit beyond what our scope is for certified ethical hackers. But if I'm a programmer, I need to know where to program certain things in memory. Useful to know how much memory I've got to work with in the first place. What else? Scrolling further on down, okay, I've got a 4 gigabyte hard drive there, okay, so it's giving me that kind of information. Just all kinds of stuff. Again, my services are running, all kinds of information that we can pull out of this kind of information. Another thing I like about this tool is that sometimes you'll run across a MIB that you're really not sure what it does or what the vendor is or anything like that. So it's kind of an orphaned MIB. You need to learn more information about it. You can go up here to MIB, search the MIB database, and then you can search the object ID. So it would be like 1.3.6.1.4.1.9, and I'll search against that one. And that will then tell me that this is nothing, because I'm on the wrong tab. I'm on search by name. I guess I should have figured that out. So I'll X that out, go over here, paste that in. What have I got? Cisco. Okay, so that's a Cisco device. If I see that kind of an object ID floating around my network, I know what I'm looking at. Now here I've gone over to the actual computer that we've been running these attacks against, or these scans against, is what I should say. And notice that we do have the SNMP service running here. And if I double click on it, this is where we can configure on the security tab the name for our community names here. So public is our read only, and then mail-private is what I configured for read and write. Well, this is where you'll also change these if you don't want to be too obvious. For my private, for example, maybe I want to change that to something else. Now, I'm going to change that here shortly offline so you don't see what I'm typing, but I'm going to show you how that we can still figure out what that is using a dictionary or a brute force attack. And to do that, I'm going to go again to my SolarWinds tool. So I'm going to go to my SolarWinds Engineers Edition, and then I'm going to go over here to Security, and then I'm going to go to Dictionary Attack in here somewhere. That's right down at the bottom. SNMP Dictionary Attack. So having gone to this then, I'm going to start a new database, and I'm just going to call it something that I've already worked with in the past here. I'm just going to overwrite that. And I'm going to choose a couple of different things. First of all, I've got to choose my IP address of my target. So I'm going to go ahead and click Edit, Add IP Address, 10.10.10.42. Click Add and OK. The next thing I need to do here then is to go ahead and choose the common community strings that I want to work with. So I'm going to click on Dictionary, and I could go down here and choose Common Community Strings. And that's usually where we'll start. However, in this case, I've already changed that to a different password that I know is not going to work under common ones. And you can see a whole bunch of other different dictionaries we have in here. Let's see. I know one of these that my name doesn't appear in. But in any case, let's keep on going. Somewhere in here, I'm trying to just find English. It's too bad they don't alphabetize these. I thought I saw an English dictionary in here somewhere. There it is. So there's English. I'm just going to scan against an English dictionary. Okay, so what did I do? I entered in my IP address using edit. I went to the dictionary. You chose the dictionary I wanted. And now I'm going to run start, and it's just going to attempt to use individual dictionary words against that system until it figures out which word works. Well, voila, it took, I don't know, maybe a minute or two, a couple minutes, but it went through all the dictionary words, 1,236 of them to be exact, and it found the dictionary word that I had entered in there, which was aggravate. So it was able to figure that out. A really cool tool to work with here. By the way, from the administrator's side of things, if you don't want people to be able to run dictionary attacks against your community strings, you just need to use complex passwords that are not going to be found in dictionaries. Just the same kind of password policies that you would use for any other secure network. And we'll talk more about policies for passwords when we talk about password cracking later on in an upcoming nugget. All right, then finally I'll show you a Linux way of also cracking this. And what I'm doing here is I've gone to a directory called, it's under USR local ADS NMP. And I'm going to type the ADS NMP command with this IP address. I'm going to use a Word file. I'm going to use a Word file from a Yiddish dictionary. And I've already gone back offline here and changed again the private password, the private community string, on my .42 box, so it's now a different word. And coincidentally, it does happen to be a Yiddish word. So let's go ahead and give this a try. Now, the only thing with this ADN SNMP is that you have to really watch this carefully because you just got to manually stop it with a Control-C. And you're going to see some contrasting colors. I think it's going to be something highlighted in blue or something like that. And so I'm just going to go ahead and let this do its thing. Might take a little bit of time here. I'm just going to give it a couple more minutes. I'm going to kind of, whoa, there we go. So when it tried the word Nebuchadnezzar, it received a packet ID from off of Nebuchadnezzar, got some results. That just tells me it's kind of crude here. It doesn't say the password is, but that's what the password is. It was Nebuchadnezzar because we saw some results there. All right, that's how we can get a password result from using Linux. All right, now finally, how do we actually change some of this stuff if we want to hack something or leave a message or if we want to be malicious or do a denial of service attack? Well, again, I just scanned against SNMP here, entered in the host name, and then just a public string. It didn't matter for this purposes. But anything that's in blue in this interface is something that could be changed under the right circumstances. Well, let me say if I want to change this vulnerable. Okay, I want to change that word to safe. You know, this is kind of innocuous, but I just could do this. So I'll enter safe and then click in a different place. But what do I get? Ooh, could not change it. And for some reason, by the way, every time you make an edit change, it takes you to the very, very bottom of all of the MIBs. And then you got to scroll all the way back up to get to the top again. Well, apparently it couldn't take that. Well, why is that? Well, that's because I'm using the public community string. Remember, I need to use Nebuchadnezzar in this case because the private community string. By the way, what's Nebuchadnezzar if you don't know? That's a biblical character from out of the Old Testament. So anyway, for some reason it didn't take and it didn't use my Nebuchadnezzar. So let me try that again. I'll enter in the word Nebuchadnezzar. If I can never get past this hourglass, there we go. And we'll try our scan again. So in case I went ahead and stopped it because it gave me the information I needed. Now I'll go up here. Now notice that since I've put in the private community string, I'll be able to put in whatever I want. Safe. Although it's really not safe, I'll just tell myself that it is. Makes me feel so much better if I just tell myself that it's safe. Now you see I was able to change that value, and I could do a number of other things here as well. I could mess around with, the network adapters. I could mess around with the routing table here. I could mess around with the IP address, the subnet mask. I could do a lot of different things for denial of service and so forth. So a pretty handy utility for the malicious but certified ethical hacker. In this nugget, we discussed SNMP. Remember, that's the Simple Network Monitoring Protocol, which has been around for a long time, but which has also been largely overlooked. So we started off with just an overview Oh, what is it? How can you use it? And how is it used in constructive network management? And then we also took a look at what the strings are. The strings are, of course, important. There's two kinds of strings. There's a public string, and then there's the private string. And sometimes they're named just that, public and private. But they should be renamed to secure that network. But if they're not very easy prey, if they have been renamed, you can hack against them using things such as dictionary attacks. And there's also things you can use such as brute force attacks as well, which, of course, would take quite a lot longer. Once you're able to hack into that using a private community string, you can alter data and do things such as create a denial of service or spoof things and all kinds of fun stuff. Well, I hope this has been informative for you, and I'd like to thank you for viewing.